When you interact with a chatbot, it is easy to assume there is a mind on the other side of the screen, actively thinking about your questions before it answers. To see what is actually happening beneath the surface, imagine finding a short movie script containing a scene between a person and an AI assistant. The script shows what the person asks, but the page is torn at the bottom, and the AI's response is missing. Now, suppose you have a machine that can analyze the text leading up to the tear and calculate a sensible mathematical prediction for the single word that comes next. You write that predicted word down, feed the newly lengthened script back into the machine, and ask it to predict the next word, repeating this single isolated task over and over until the dialogue is complete. If a chatbot is performing the same basic function as the autocomplete on your smartphone, you might wonder why it produces highly coherent dialogue instead of a repetitive string of nonsense. The illusion of sentience is a byproduct of performing one simple mathematical task at an incomprehensible scale. The first mechanical hurdle is that computers cannot process English letters. To perform any calculation, the vocabulary must be translated into continuous numerical values. The system achieves this by taking individual words and breaking them down into long numeric vectors. These lists act as coordinates that mathematically map the abstract meaning of the corresponding word. By stripping away the letters and organizing the dictionary as a vast map of geometric coordinates, the relationships between human concepts become something the machine can formally calculate. Older models processed words sequentially, reading from left to right like a human. This created a severe computational bottleneck, limiting the amount of context the system could track. The 2017 transformer architecture absorbs entire passages simultaneously. Its core, attention, lets independent number lists communicate to refine meaning based on context. For example, the numeric value for bank actively shifts if water is nearby, representing a riverbank instead of a financial institution. Through the attention mechanism, rigid dictionary definitions are transformed into a dynamic, fluid map of contextual understanding. The behavior of this system is governed by continuous values called parameters. Modern models utilize hundreds of billions of these individual tunable dials. Parameters begin with random values, initially outputting pure gibberish. During pre-training, the model ingests trillions of examples. Every time it fails to accurately predict the next word, an algorithm tweaks the dials to make that correct word more likely in the future. To illustrate the scale involved, if you could perform 1 billion calculations every second, it would still take you over 100 million years to finish the math required to train a single large model. However, a model that simply learns to autocomplete the random text it finds on the internet does not automatically become a helpful assistant. To fix this, human workers manually flag unhelpful or problematic outputs. These corrections further adjust the parameters, guiding the model toward the specific behaviors users prefer. While raw computational power builds the engine's capacity, human curation is required to steer that capacity toward usefulness. There is one final mechanical secret to a chatbot's conversational tone. The system does not always choose the word with the highest mathematical probability. It is often programmed to select less likely words at random. Injecting this slight unpredictability into the output allows deterministic code to produce a result that feels organic and conversational. Because hundreds of billions of parameters interact during every prediction, no human programmer can actually explain the specific logic that leads to one final word choice over another. This is an emergent phenomenon where massive scale combined with simple mathematical rules creates a complex, unintended result. The result is a system that produces uncannily fluent and useful dialogue. It demonstrates that with enough data and computational scale, a machine can mirror the patterns of human expression through pure calculation.